We'll start with a very down-to-earth equation. Y equals 1/3 x. And I'm going to plot that for you. So here is y, and here is x. And that's a straight line through the origin. Y equals 1/3 x. Suppose now I want this line to move. I want this line to move with a speed of 6 meters per second in the plus x direction. All I will have to do now is to replace x in that equation by x minus 6t. Notice the minus sign. I will go then in the plus x direction. The equation then becomes y equals 1/3 times x minus 6t. And so look at it at t equals 1. At t equals 0, you already have the line. At t equals 1, you now have y equals 1/3 x minus 2. That means here it will intersect at minus 2, and here it will intersect at plus 6, and the line parallel to the first one, this line is now t equals 1, and this is t equals 0. And it has moved in this direction with a speed of 6 meters per second. And so what this is telling us, that if we ever want something to move with a speed v in the plus x direction, then all we have to do in our equations to replace x by x minus vt. And if we wanted to move in the minus x direction, then we replace x by x plus vt. That's all we have to do. So now I'm going to change to something that is a real wave. I now have y equals 2 times the sine of 3x. That's a wave. It's not moving, not yet. So I can make a plot of y as a function of x. And that plot will be like this. This is 0. When the sine is 0. This is pi divided by 3. And this is 180 degrees, and it's again 0. This is 2 pi divided by 3. It's again 0. And lambda, which we call the wavelength, lambda, in this case, is from here to here. That is 2 pi divided by 3. It's, of course, also from here to there. I will introduce a symbol k that you will often see. We call that the wave number. And k is simply defined as 2 pi divided by lambda. So in our specific case, k is 3. This here is k. If you know this number, you can immediately tell what the wavelength is. Now I want to have this wave move. I want to have a traveling wave. And I want to have it move with 6 meters per second in the plus x direction. So the recipe is now very simple. All I have to do is replace this x by x minus 6t. So now I get y equals 2 times the sine times 3 times x minus 6t. And if you now look at this curve, this equation, and you plot it a little bit later in time than t0, this is already t0, a little later in time, you will see that indeed it has moved in the plus x direction. And it's moving with a speed of 6 meters per second. So this equation, when you look at it, holds all the characteristics of the oscillation. It holds the amplitude. This 2 is the amplitude. This is minus 2. That's the amplitude. This information, k, holds the information on the wavelength. And this information tells you what the speed is. And the minus sign, which is important, tells you that it's going in the plus x direction and not in the minus x direction.